When we are studying two variables at a time and we want to try to determine whether or not those variables are related to each other, if there's a relationship between the two values, then sometimes a scatter plot can help us to, at least in the beginning, to see what we're working with. Okay, understand that what we're going to be doing in this section is plotting points. We're not looking at continuous curves or sketching normal distributions. We're just plotting points, putting dots on our page. And then we're going to estimate with our eyes whether or not we believe a relationship might exist. Okay, we'll quantify those relationships as we move down through the sections. But today we're just going to put some dots on the page and write down what we see. So when we have a scatter plot, instead of just collecting one variable of data, the number of heads that we flip when we flip a coin, or how many seconds it takes for you to run 100 meters, we have both an x and a y variable. Now the x coordinate or the x variable is our independent variable. And as we get a little bit more in depth with this, this is the one usually that we have control over, or that we're recording, maybe an amount of time that you exercise, or how many days that you are working on some project. Okay, and after we've controlled that input, the dependent variable is whatever comes out. Again, when we are graphing, usually, of course, if we had graph paper or just wanted to sketch in our notebook, we could draw those points, but I'm going to show you one of my favorite websites. If you have one that you like better, feel free to use it. But you can use computer assistance on the graphing parts of these sections. Okay, remember from algebra class that our x-axis is the horizontal axis, and positive x coordinates are to the right. Positive 1, 2, 3, 4, 5. Our negative x values are to the left. Our vertical axis is the y-axis, our second coordinate of the ordered pair. Up are our positive values, and down are our negative values. So just to practice for a moment, if we wanted to plot the point 2, 3, okay, from the origin is the place where they meet, they intersect, and that's at 0, 0. We would go right 2 steps and up 3 steps. If I wanted to plot the point -1, 4 from the origin, I would go left 1 and up 4. Now when you plot points for me, I'm going to ask that you always label them. So tell me where you are aiming. Even if you're using a computer system, make sure that you turn on the point plotting so that we can see those labels. If I wanted to get to the point 3, -4, I would go right 3 and down 4. Now, one of my favorite websites that I enjoy using is Desmos. It's Desmos. And if you haven't ever been to desmos.com, again, even if you have a graphing utility that you can hold in your hand, your TI-82 or 3 or 4, you're going to need to turn graphs into me. So unless you have a way to get those off of your calculator, then you're going to want to use either this website or another. Now the nice thing about Desmos is it's pretty user-friendly. If I can figure out how to use it, then I know you guys all can as well. Maybe I want to plot the point 5, -2. Okay. I opened my parentheses. Maybe I'm talking while I'm clicking. I put open set of parentheses and notice it closes one for me. I type in the x coordinate, -2, comma 7, maybe. If I want Desmos to put that label on my graph for me, I check mark the label, otherwise it's not there. And I look and say, well, I don't really see the point to -7. Whoop, that's not what I meant to do. Click the wrong button. You can drag your graph up and down. Here's a zoom in and a zoom out feature. Okay. And when you're done with that ordered pair, you hit enter and it gives you another box. Okay. All right. If we are looking at points on a graph and we're looking at our scatter plot of values, if our dots kind of increase as we move from left to right, okay, as we move from left to right, if they increase, and they look like they increase kind of in a straight line. And when we say straight line, notice that none of these are on a perfectly straight line for us. Okay, but they do kind of go up, they don't curve, there's not dots that go dot, 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 dot. And so we say this might have, or at least look like it might have a positive linear relationship. Again, we can't quantify that in this section, we're just looking with our eyes and seeing if that seems to be the case. If our dots go down, and again, not in a perfectly straight line, but in a way that they don't go skewing off one way or the other, they're not a big blob on the page. Okay, that line has a negative slope, and so we say it has a negative linear relationship. If our dots maybe I'm trying to make it kind of a blob looking thing here, okay, aren't in a straight line, but look like maybe they follow some sort of shape. That sort of follows a curve. Okay, sort of. Then we think that it might have a relationship, but to some other curve, and that's outside the scope of this class. We're going to look at lines and linear regression here in a little bit, but we're not going to worry about logarithmic curves or exponential curves or quadratic relationships or anything else. Okay, so I'm just going to write some relationship, not a line. Okay. If the dots on our page are just a sea of dots, just a scattered mess, okay, then our conclusion, especially our very simple conclusion in this chapter, because we're not quantifying anything, simple meaning I'm just kind of telling what I see and I'm not quantifying anything. Okay, we say this looks like it has no relationship at all. This is just a scattered mess of dots. So if our scattered dots go up from left to right, and again, not make a perfectly straight line, but sort of go in that direction, okay, then we say it has a positive linear relationship. It looks like it might. If those dots go down, again, not in a perfectly straight line, but sort of in a linear blob, I'll say, we say, well, it looks like they might have a negative linear relationship. If they follow some sort of curve, and maybe I'll knock that guy out of there, they follow some sort of curve, again, not perfect, but definitely not a line, then they have a relationship, we think, to some other curve, but we're not going to worry about what it is. And if they're just a big massive blob, then we say, I don't think there's a relationship there at all. So in the next video, we'll actually draw some scatter plots, and then we'll write down our comments, because the book will ask us, after you look at your dots, what do you see and what conclusion might you draw from them? Okay, so next video we'll pick up there.